Okay, so the next question that we're looking at today is the total surface area of a right circular cylinder of radius r and height h given by s is equals to 2 pi r squared plus 2 pi r h there, and s is a constant. We need to find dr dh there. So now to do that, we're going to get this expression here and we write it here. We have s is equal to 2 pi r squared plus 2 pi r h like this. So now how we solve this here, we're going to differentiate throughout because we've been taught to say we find dr dh, meaning that we differentiate this whole expression that we have here with respect to h. So to do that, we just put a statement there, differentiating throughout with respect to h. So differentiating throughout with respect to h there, we're going to show that we're differentiating this expression with respect to h. We'll introduce this here. So we have dh is there equal to, we also differentiate this term here. We should to say we're differentiating that term there with respect to h of 2 pi r squared plus, we also show that we differentiate this term here with respect to h, dh there of 2 pi r h like this. So then if that's the case there, we can start performing our differentiation there. So now we know to say in the question we've been told that s is a constant there. So if s is a constant, we know every time you differentiate a constant with respect to any variable, you just get 0 there. So we're going to have 0 this side. So now when you look at this term here that we want to differentiate there, we're differentiating r with respect to h, which is a completely different variable from r there. So what we do there is we're going to differentiate this the normal way. So when you differentiate this the normal way, you're going to get 4 pi r like. So now since this r is being differentiated with respect to a different variable h there, we introduce dr dh there. So this method of differentiation is what we call implicit differentiation. Plus, so when you look at this term here, we've got r and h there, meaning that we've got two functions that are being multiplied by each other there. So if you have two functions that are being multiplied by each other, the differentiation method that we use there is the product rule. So the product rule, we keep the first function, differentiate the second, and you keep the second, you differentiate the first function. So to do that, we're saying you keep the first function, which is 2 pi r there, differentiate with respect to h, the second function, which is just h, plus we keep the second function, h there, differentiate the first function, 2 pi r like this. So now, since we've done that, we can go ahead and just differentiate these terms there. So this side, we maintain the 0 that we have equal to 4 pi r dr dh, plus when you differentiate h with respect to h, you just get 1. So we have 2 pi r there, plus, so now if you notice here, we're differentiating this r there, which is a different variable that with what we're differentiating it with respect to. So now we're differentiating this variable r with respect to h there. So we're going to differentiate this the normal way. So when we do that, we're just going to have 2 pi h like this. So then since these two are different variables, we're going to introduce dr dh there. So this is what we call implicit differentiation there. So now the only thing that remains there is the question requires us to find dr dh. So we can just factor out, we can just group everything that has dr dh, we put it one side, and we take this, it crosses the equal sign there. So we have 4 pi r dr dh plus 2 pi h dr dh there equal to, when this crosses the equal sign this side, we have negative 2 pi r like this. So now, this side, what only remains this side is we have to factor out the drdh there. So factoring out the drdh, we're going to have open brackets 4 pi r plus 2 pi h. We keep the drdh there because it's the only common thing amongst these terms that we have here, equal to negative 2 pi r like this. So now, since we've been taught to say we find the rdh there, so what we do here is we divide both sides by 4 pi r and 2 pi h there. So when we do that, we divide this side by 4 pi r plus 2 pi h and divide this side by 4 pi r plus 2 pi h like this. So then this side, these will cancel, so meaning that we're going to have our drdh there being equal to negative 2 pi r over 4 pi r plus 2 pi h like this. So now, when you look at all these terms that we have down there, they've got something in common that we can factor out. So if we factor out the 2 pi there, so we're going to have the rdh being equal to negative 2 pi r there over 2 pi like this. And then here what remains is going to be at 2r plus there we just remain with h like this. So you notice to say the 2 pi there and the 2 pi on top is going to cancel out, leaving us with the expression there. So leaving us with the expression equal to negative r divided by 2r there plus h like this. So this becomes the dr dh that's required there.